Lesson 22 is proving similarity in triangles using their angles. So in 22.1, we learned about a new rule that allows us to only need two angles, two pairs of angles, two from each triangle, to show that two triangles are similar. So remember, similar triangles, those are triangles that have all the same angle measurements, but they're different sizes. So they are kind of related proportionally, meaning like one triangle, all the side lengths may be exactly double of the other triangle, or one may be like a third of the other triangle. So they are proportional, they are the same general shape, they just have different kind of overall sizes. So starting up in the top left, the angle-angle similarity postulate. So if two angles in one triangle are similar to the corresponding angles in another triangle, then the triangles are similar. So if we look at the kind of graphic in the upper right, there's two pairs of corresponding angles that are congruent. A and K, those are corresponding and congruent, and then B and L, those are corresponding and congruent as well. And then just by default, like if those all have the same angle measurement, there's only a certain amount left for the third angle because every single triangle out there has to add up to 180 degrees. So if A and K are the same and B and L are the same, they have the same amount left over for C and M if they all have to add up to 180. I'm going to add just like some actual values in here to kind of help make sense of it. So let's say, for example, angle A is 110 degrees. Angle B is 30 degrees. That would mean that K is 110 degrees as well, and L is 30 degrees as well, because A and K are congruent, so they're the same measurement, and so are B and L. And every angle in a triangle has to add up to 180. So let's say I add the two angles that I know from triangle A, B, and C. 110 plus 30 is 140. And that means that if I can only go up to 180, then I only have 40 degrees left over for C. But it also means I would only have 40 degrees left over for M as well, because the first two angles took up the same amount. Okay, so just kind of angle triangle similarity works because if the first two angles that you know in a triangle take up, like, I don't know, say for example 100 degrees or 150 degrees, there's only going to be the same amount left over for that third angle. Okay, so example 1, are these triangles similar? So in this example, we don't necessarily have two pairs of corresponding angles, but we can definitely get them. So right now we have the two angles that are 77 degrees. So those are corresponding and congruent, so those are fine, but we don't have a second pair. So we know this is 13 degrees, but that would be corresponding with this angle down here, and I don't know that one yet. And then this is 90 degrees, but that would be corresponding with this angle right here, and I don't know that one yet. So I just need to find one of the missing angles and see if it matches up with the like kind of known angle from the other triangle. It doesn't matter which triangle you pick, just pick blue or red, and then we'll find the missing angle in that triangle. So I'm going to pick blue. So we know that all the angles in a triangle should add up to 180 degrees, and we don't know this angle right here, so I'm going to call that x. I'm going to add up all the angles, create an equation, set it equal to 180. So I'd say 13 degrees plus 77 degrees plus x. So that's this angle, the 77 degrees, and then the unknown one is x. And all three of those added together is equal to 180. So first I can add the 13 plus 77, that would give me 90 degrees. Plus x is equal to 180. And then from there, if I'm trying to solve for x, I would need to get the x by itself. So I would subtract 90 degrees on both sides to cancel out that 90. And then I bring down my x, and then 180 minus 90 is 90 degrees. So that means that this angle over here is 90 degrees, and that corresponds with the angle on the red triangle that had that right angle box. So they're both 90 degrees. So now we have two pairs of corresponding angles that are congruent. That's enough to say that yes, they're similar. And if you wanted to, you could absolutely use like that same approach, like kind of setting up this equation in order to find that third angle of the red triangle, but it's just not necessary. That's the point of this postulate, is that you only need two pairs of angles. As soon as we get that second pair, we're done and we can say that they're similar. Okay, so example 2, are these triangles similar? So like something that should pop out right away is the like two right angle kind of markers. So angle B and angle D, those are corresponding and congruent. And then we kind of just want to pair up like what are the other pairs of like corresponding? Like don't even worry about the congruent yet, but like what angles go together. So the like kind of, let's picture this angle is like flipped upside down. So that means that angle A and angle E, those would be corresponding, meaning like they're kind of related to each other. You know, like if one, they match up with each other essentially. And then for angle like C, both sides of it, those would be corresponding. So the left side of angle C and the right side. So the like both sides of angle C, so I guess it's ACB and DCE, those are vertical angles. So like these two angles right here are vertical angles because they're created from like an intersection of two lines. And vertical angles are always congruent to each other. So we know that ACB and ECD, those are both congruent. So we have those and we have the right angles. So we have two pairs of corresponding angles that are congruent. So that's enough. I don't have to worry about angle A or angle E. So I can say yes. And then these triangles like have the sides labeled, the other one didn't. So we can write it more in like kind of the math syntax. So we could say triangle A, C, B, and then is similar is like the one little squiggly line is similar to triangle. And then remember, we want to match up the corresponding angles. So A and E, those went together. So since this started with A, I'm going to start mine with E. And then next was C, so I'm going to put C next. So E, C, and then the last one on the kind of first way we wrote it was B, and the angle that corresponds with B is D. So D at the end. So yes, triangle ACB is congruent to triangle ECD. Okay. Before we move on, I don't know if I have one of those things where I was like, just misspeak. I might have said this was congruent. If I did, I meant to say similar. Yes, they're similar. So triangle ACB is similar to triangle ECD. Okay, so 22.2, using angle in proof. So this just has one example, but it's a proof. So 22.2, we're going to take these two triangles, triangle ABC and triangle XYZ, and prove that they're similar. So all that we're given in like kind of this graphic is that we have a few angle measurements. So that's the first thing we want to state that's given to us. So it's just all the angles that are given. So like the measure of angle A is 65.77, measure of angle B is 68.69, or sorry, 78.69. The measure of angle Y is 78.69, and then the measure of angle Z is 35.54. Okay, so what we're going to do for this proof is kind of just the more formal process that we use for example 1 up here. So like first, for example 1, we set up an equation. I want to kind of create like a formula for that equation. So this equation that we set up was based on the triangle sum theorem, which just says that, you know, all three internal or interior angles of a triangle add up to 180. So that's going to be our statement number 1, is we're going to say, and we're going to go based off the blue triangle, but if you wanted to, like, you could use the red as well. But for number 2, or statement number 2, we're going to say the measure of angle A plus the measure of angle B, plus the measure of angle C is equal to 180 degrees. So we just kind of took like what we did for the very first part of example 1 up here, and we just wrote it in more general terms, like without the actual measurements in there, the degree measurements in there. So the thing that says that all three angles add up to 180 degrees, that's called the triangle sum theorem. So for our reason, it's going to be triangle sum theorem. And then for statement number 3, we know some of these angle measurements, so we can just go ahead and substitute them in. So for like the measure of angle A, that's 65.77, I can put that there. The measure of angle B, 78.69, I can put that there. And then we don't know C yet, so we'll just kind of leave that as is. So the measure of angle A, that was 65.77 degrees, plus the measure of angle B, 78.69 degrees, plus the measure of angle C, which we don't know yet, is equal to 180 degrees. So we just took like what we know for A and for measure of angle B, and we substituted it into the equation, so that is the substitution property. So for reason number 3, we would say substitution property of equality. Okay, and then now just like forget for a second that this is a proof, like what would you do with the equation for number 3? Like what would be like your natural instinct to do? It would be to add these two together because like you can, so why not? So we'll go ahead and just like simplify that equation by adding those two together. So 65.77 plus 78.69 is 144.46. So 144.46 degrees from adding like these two together. And then still don't know the measure of angle C, so we'll just bring that down. Measure of angle C is equal to 180 degrees. And then if you're like, okay, well, what is the reason? Like I just added, that is the reason. Like addition. Like that's a math word. We can just say addition because that's what we did. Add or addition. Okay. And then for number 5 now, again, like kind of you can almost kind of like disregard that's a proof and then come back and worry about it like once we have to get to the reasons. So if I was looking at statement number 4 and I was like trying to solve for the measure of angle C, what would I do? I would subtract this 144.46 from both sides. So you don't have to write this in your proof, but I'm just going to kind of write it under there like a little bit small so we can see like what the process would actually be. 144.46, subtract that from both sides. And then I'll probably erase it after. So I'll have the measure of angle C is equal to 180 degrees minus 144.46 is 35.54 degrees. Okay, and then for the reason for number 5, this one, like, I know we just put like add for like number 4, but we were able to just put something like as simple as addition because we were just kind of adding on the same like side of the equal sign. Whenever you're doing things to kind of like both sides, you have to use like a property of equality kind of version of something. So in this case, it would be subtraction property of equality. So for like the just regular old addition, that's like, you're just like combining like terms on the same side of the equal sign. If you see like addition or subtraction property of equality, it's like when you have to add or subtract from both sides of the equal sign to kind of keep the equation balanced. Okay, and then now we kind of like have enough information to show whatever two pairs of like corresponding angles are congruent. So I'm just going to kind of go ahead and add in the like 35.54 degrees into my graphic. And then we know, okay, so B and Y, those are corresponding and congruent. And then now we know angle C and angle Z are corresponding and congruent as well. So we have to state that they're congruent for 6. So we'll say angle B is congruent to angle Y, and angle C is congruent to angle Z. And we were able to show that because they have the same angle measurement, and that's just what congruent angles are they're angles with the same exact measurement. So for 6, we would say definition of congruent angles. And then now we have 2 pairs of corresponding angles that are congruent. So that's enough to say that the 2 triangles are similar. So we can say triangle ABC is congruent to triangle, and then we just want to make sure that we match up like the correct lettering. They have it like kind of written up here, but I always think it's kind of good to practice it together. So we know like B and Y, those are the same. Those are going to be congruent and corresponding. C and Z are corresponding, and then the last pair is going to be A and X. So since we started with A over here, we have to start with X over here. And then B, that corresponded with Y, so Y would go second. And then C, that was last, and that corresponded with Z, so Z would go right here. So triangle ABC is similar to triangle XYZ, and that's by that postulate that we just talked about. That's the angle similarity postulate. Okay, so angle similarity postulate, just basically that you only need 2 pairs of corresponding angles to be congruent in order to show that the whole triangle, both triangles are similar.